Hello everybody, welcome back to another show of Ask the Trainer. And today I'm joined by, again, a few really cool people. We have Noseman here, we have Darren here, we have Ellie here, and we also have Sassy in the background. Yeah, today we want to talk a little bit about fields, but before we do that, I want to take care of a little bit of housekeeping here, as always. So that's the wrong screen, here we go. And yeah, if you go to maxon.net/events, then you get to this site, and here you can find all of the free webinars we are doing. So you can register here, and if you want to rewatch the session today, then you can go to the Maxon Training Team YouTube channel, and you find everything we do here. And yeah, then there is this other topic of certification where, well, and this is the base for the Ask the Trainer sessions, at least this one and the next one. And because we want to make sure that people who want to become certified artists or pro users can get there and find some learning resources. And if you go to the Cinema 4D Basics Comprehensive Certification Test section here, you find the list of certification topics. And this is what we are, yeah, going to, this is our foundation for this pretty much. All right, so let's do one more thing. We have some t-shirts for you, and if you we want to thank you for attending. So if you want to have a t-shirt, you can get one for free. You will find the link in the chat and also the passcode that allows you to order a t-shirt for free, so you only have to pay for the shipping. Great. So with all that being said, let's jump into Cinema 4D. And also another thing that I want to show here is After Effects. Today we're going to talk about fields, and the concept of fields is pretty easy to understand if you think of it as like three-dimensional masks. So here in After Effects I have a white solid with two masks on it. So here's a circle mask, and I can move that around. I can adjust the feathering and stuff like that. I can do the very same with the rectangle here. And this is pretty much the same thing as fields, but as you can see here, this is two-dimensional. And if we go to Cinema 4D, you can see that we have the same thing in 3 dimensions. So what I can do here is I can grab any of these fields. Fields are masks in 3D space, and you can see the equivalent of what you just saw in After Effects here. So what is happening? All right, I have those colors here, black and white, and you can see that everything that is white is fully weighted and everything that is black is not weighted. And you can also see that we get the values here, and we can just move all of these fields around, and we have those values in 3D space. So weights in 3D space, that's what fields are. You can see that here again, that it's all three-dimensional. And now the question is, where can you use fields? And I prepared another scene for that, because fields can be used in a variety of scenarios. And the first one is, of course, MoGraph. So if you ever heard of fields, it might probably have been in the MoGraph context. So what I have here is a scene with just a spherical field and some different setups. And I'm going to use this one field to drive all of these different setups. So let's start. Here we've got MoGraph, so you can use it to affect clones. But you can also use fields in deformers. Here you can see that, I'm deforming this this plane here with the Voronoi noise on it. Then you can also use fields in vertex maps, and this is a quite important one, because vertex maps, again, can be used like in materials, for example. They can be used in cloth and many more things. Then we can use fields inside of selections, polygon selections, edge selections, point selections. Here you see a point selection. And we can also use fields to create volumes. That's also a very interesting use case. And then you can see here on the right side, nothing is happening because I have to press play. So there are two things that I have here. Once I press play, you can see the first one, that's a turbulence field. And once I move this field in here, you can see that the turbulence is happening, and we're masking the turbulence with this field. And then there is another use case, which is the last one here. It's force. So what we're doing here is not masking another force like wind or turbulence and so on. So we're actually using fields to create a force. So by using this spherical field, I can, for example, make clones or dynamic objects be attracted by that field or pushed away from that field. So you can use fields in all of these scenarios and a few more. Those are just a few examples. I'm sure I forgot one or the other thing, but yeah, you can already see it. That's just 8 cases, and I didn't get to everything here. So that's what I wanted to show first, that you get an understanding of what fields are. They are weights in 3D space, and it's also a unified weighting system all over Cinema 4D. And I also showed you a few use cases already. And yeah, with that, I want to switch to Noseman so he can explain a few more things. So you have the screen.
Hello. Yeah, I'm audible, I would guess. So this
Yes.
beautiful image here, just let it sink in, this beautiful face. So
It's so beautiful.
I'm going to expand on what Jonas just said. Now, to understand, first of all, we forgot to say something important, that on Tuesday, the 29th of March, 12 noon Eastern time, we are having a Zoom chat. I'm going to host it alongside some of the other trainers, where you can ask live. You can share your cameras, microphones, and all that for 1, maybe more hours to discuss specific things you want to ask about the certification process, both for users and for instructors, trainers. So just look out over the next few days through Maxon's or my Twitter account, and we will announce the link. You don't need to register. You just click it. You can come and chat your questions, type them in, or you can ask your questions on camera. And generally, we want to address a variety of questions that appear and have a conversation with you so we can explain the context and all that. So just look out on Twitter. And when you get that, please share it amongst your peers for anyone that's interested. Back to our usual program. So to understand, to be able to work with fields and be able to uh, provide the solutions for the questions for the test, and of course, so you can learn how to use them. The easiest way to understand what a field list does in the context of MoGraph, as Jonas said, they're 3D masks. And here is an applicable example. So imagine the following thing. You need to make this leap of imagination. Imagine if this image, now if we zoom in, you see that everything is a square pixel. Imagine if each and every one of these pixels, which are differentiated by color, right? So each one has a different color, and the totality of this gives us a grid of little squares that is our final, it's our data, it's our cloner. Imagine if you have a cloner or a matrix object that is generating adjacent cubes. So imagine this footage of being the bottom part, the base of what we are creating in Cinema 4D. In this particular case, a matrix or a cloner with little cubes. Now, the effector is an adjustment layer, and this adjustment layer has two effects on it. The effects in After Effects are the equivalent of Cinema 4D's position, scale, rotation, weighting, all the parameters you will find if you go to an effector in the parameters. All these are parameters we can change for each and every one of the clones. So try and make again, the leap of imagination, the connection that the effects we're applying on this adjustment layer are the data we are changing. And because in After Effects, the only thing we can do is change the color of the pixels, whereas in Cinema 4D, we can change position, scale, rotation, and so forth. Just imagine it as changing the original state of that data. In this particular case, color. Now, I'm going to apply this. I'm going to do no track mat. And you can see that an effector without any masking will apply these effects to all our individual little squares, the clones in this case. And this is what we get. And you can turn effects on and off and do whatever else you want. The field list, if you go to Cinema 4D and look at the field list in here, this field list is populated by a number of masks that indicate how much of the values we are changing are going to be propagated to our original footage, right? This is Noseman. This is Noseman with the adjustment layer. So let's go back to After Effects. The field list in this particular case, I'm representing it using a pre-comp. And in this pre-comp, we have a circle. So this is a black and white image. So imagine this being a spherical field where the inner boundary is the blue line and the outer boundary is the outside. Again, this is exactly the same analogy you'll find within fields. And the way we're going to use this is we're going to tell the field list to mask the effects of the effector using a Lumimat. And this, what I just showed you, that the effector is just an adjustment layer equivalent, that an image or a video footage is the bases, are clones, and the field list is a pre-comp populated with black and white grayscale masks. This combo you see here is exactly what we are doing inside Cinema 4D. This is here is my footage. On my footage, I'm going to apply an adjustment layer that changes the scaling. Let's go to uniform scaling. You can see everything scales. And in the field list, we're going to add those black and white images that are going to allow the effect of the effector to go through. Once you understand the analogy in After Effects, which I understand that most of you use After Effects or an equivalent compositing program that has the same concepts, by transferring that knowledge into Cinema 4D, you essentially have the main understanding of how fields work in MoGraph, and to an extent to every other parameter. So let's go and look at a very simple example. When you're learning how to use fields, there are certain principles you need to understand in the field, what the remapping means and all that. So for this particular case, I've created a very simple matrix. It's just 40 clones by 1 by 1. Okay, so we have these adjacent clones. And to this matrix, all this text is just to populate the scene so you can see what happens. Now, by definition, the field list works in normalized values. A normalized value is 0 to 1. And that's equivalent to After Effects or Photoshop's masks, because a mask can be anything between black, 0, and white, which is 1. So this is a normalized mask. Now, the field system has more capabilities than a simple masking system in After Effects and Photoshop, but imagine that for a moment. So the plane effector is moving these up by 100 centimeters. So here's the baseline, 0. They're sitting over there, and I've turned it off. If I turn off the field, it becomes invalid in here, so it's not going to work. There you go, I invalidated it. So everything now is moving up by 100. That's because the full application of the effector is being applied to all these clones in the Y position parameter. Now, let me turn this back on. And this is a linear field. And the linear field is depicted by these two squares and a line and a little arrow right here. The arrow indicates the maximum value. And in its default state, and there you go, there was a refresh issue. So 0 value, this is the 0 and 100% 1 is the value that's inside the field. If I move it around, you can see that these values shift. But this indicates that 0% of the maximum value is propagated to the clones. This point here where the arrow is means that 100% of the values are going to be propagated. That's why you see this ascending thing. Imagine this as a linear gradient where we have the maximum and there we have the minimum. So this is the first thing to understand. The next thing to remember is that although by definition the list works in normalized space and all the values are from 0 to 1, the field list can actually generate values that are higher than 1. And this little button over here is the field list clamp. And we can add more fields here and do mathematical operations. These are simple mathematical operations which are very similar to the transfer functions we have over here. Addition adds the colors, multiplication multiplies the colors, and so forth. And here we do the same thing. Again, imagine this as three-dimensional black and white images, gradients. Now, what I'm going to do is, first of all, show you in terms of each field how these values are generated. Now, if I click on the field in the list or click in the attribute manager, I'm presented with a list of tabs, one of them called Remapping. And what you can see, these are self-evident. You can see it switches over. And we can see here that the minimum value is 0. The maximum value is 100. And these are both clamped. Now watch this. There's a combination when using this clamp and when using this clamp. And if it becomes a bit convoluted, you're going to realize in a second exactly how this works. This clamp here, what it does, it removes any value above 1 or any value below 0 after all the list has been evaluated. So what I'm going to do here is take the same field, because I can do that, and add it a second time in the list. And I'm going to add it. And it's just adding the values, right? That's why you see this gradient now is going up at double the rate, because we have 2 times the same value. So 1 is going to be reached at the halfway point, because it's 0.5 added to 0.5 equals 1. But you can see that no value of the list, the total list calculation, can exceed 1 because this is clicked. The minute I uncheck this, then these values are going to go to their maximum. So that's why we have now here values from 0 to 200%, because we're adding a 0 to 100 to 0 to 100, and we get 0 to 200%.
And
But
that's from the two linear fields on top of one another, right?
sorry?
And that's from the two, just from having the two linear fields on top of one another.
Exactly, because the only thing you need to remember is that at each position where each clone lies by default, what is the value of the field? So here it will be, let's say, 5%, 10%, 15, 20, 25, 30, right? This is 30% is 0.3. 0.3 times 100 and 2 times 100 is 200, because we have two linear fields. It's simple math if you think about it. You can number these and see it interactively. The essence is that this clamp, it doesn't allow for values lower than 0 and higher than 1 after all the calculations have been performed within the list. If we want the values of each field to exceed that 0 to 1, we have to go to the field itself. And let me turn this off for a second. I'm going to go to this field, and you can see that from 0 to 100%, if I unclamp the 100%, now it's going to go on forever. 0 is here, 100 is here, and as long as this continues, if I go to the matrix and increase these, we're going to get more and more and more. And the same thing applies to the minimum clamp, which goes downwards. So these clamps control the values that are extending beyond the boundaries of the field itself and allows them to just go to infinity. And this clamp controls how much of these values are going to be allowed after all calculations have been applied. So watch this. If I turn this on, we're going to see both the extremes after values are higher than 1 or values are lower than 0 are going to be clamped. So they're going to stay within the highest range or the lowest range. And basically, this is the logic behind fields. This is how fields work. We add these gradients here, 3D gradients, 3D masks, you can call them whatever you want. We call them fields, by the way. You can do additions, you can do multiplications. If I multiply this, it's funny because I create nice parabola. And again, you can try this using your little Texas Instruments calculator from the 1989 or something like that. But you can do fancy stuff with these sort of blending modes, which are just simple math. Now, one thing, min means the minimum between two values. I'm not going to expand too much on that because I'm showing some examples in Photoshop of what min, max, add, screen, and all that mean within the context of Photoshop using pixels. If you follow the link to the Cineversity tutorial where I have a series talking about fields, and most of the stuff I say is still relevant. A couple of things have changed in the interface, but other than that, everything works. Now, the last thing I want to say about fields, I'm going to go back to this one over here, just for the fun of it, is that within a field list, I have matrix, I have a plane, and it's just, let's make this -1. It's making them 0 scale, essentially. And in here, in the field list, we can drag pretty much any Cinema 4D object. There is some may be excluded, but we can drag in particles, we can drag in mesh objects, we can drag in splines, we can drag in MoGraph objects, and so forth. And it uses the structure of those objects to do what we want to do. And I'm going to show, I'm looking at my notes to make sure that I didn't forget anything. Yeah. So the one thing I want to show, just to make it a bit more understandable, is I'm going to take this huge matrix object, and at the same time, I'm going to get a sphere, and I'm going to put this sphere inside a volume. Now, when you're using volumes, the sine distance field is not the appropriate method if you're going to use it within fields. The best one is to use the fog, because the fog generates values from 0 to the surface to 1. And if you select this and say maximum voxel fall off, it will find the furthest point from all the surface and make that 1 and gradiate out to 0. Now, if I'm going to make this invisible, I'm going to turn this on and I'm going to drag this in here. And you can see in some cases, the field list is going to ask us, do we want to take the points of that object or the volume? In this particular case, I want a volume. Now, you can't really see what's happening because it's happening inside. If we go inside here, look at this big cavity. That's because the cubes are becoming, the matrices are becoming smaller inside this. So all I have to do is go to the volume builder in the remapping and turn it on, because for certain data types, it's off the remapping, and just invert it. And there you go. So now the scaling of the matrices is occurring. Let me turn off the color. Is actually occurring based on the values of that fog volume. So the permutations are literally infinite. And over the next 1 or 2 sessions, we are going to create actual setups that use all the knowledge we have talked about in the last 3 sessions about MoGraph, effectors, and fields. So that's all I have to show. If you have any questions as well, please share them. This is just a setup with thinking particles where they're modifying. And these are more complex setups we're going to see in some of the other sessions. But overall, try to do this very simple setup for yourselves, which will be, before I close, just to make a matrix, make it linear, go add an effector, set the parameter to 100. So you have, if you go to the front view, every grid line is 50 and 100. And over here, go and add fields and try and see what's going on. Oh, the final thing I want to say about this is there are 3 types of parameters that the field list can control. The squiggly line is the value, the 0 to 1. The color is the color. And if you have your effector set to fields color, it will create the MoGraph color based on that. And the third one is direction. And direction basically applies to specific effectors and particles and stuff like that. In the case of the plane effector, it doesn't apply. But if you bring up something like a target effector, in the fields list, you get value and direction, orientation. And we are going to show some setups that utilize this over the next session or 2. So I think, yeah, I've wrapped up for now, and I'm going to prepare if there are any questions. You have the floor, Jonas.
Very well explained, man. So yeah, if you have any questions, just ask. Or are there questions already in the chat that we can bring up here? Well, no problem if not. We have enough stuff to show.
I haven't noticed any. Have you, Ellie?
No, not yet. But
okay.
Yeah, any questions, guys, then drop them in the chat and then we can ask them live.
Great. In this case, I'm going to continue here. So what I want to do now is I want to show you some of the fields. And first of all, I'm not sure if you mentioned it, Thanasis, but the thing about fields is that a field itself does nothing. It's just creating a weight. You have to assign it to something inside of Cinema 4D to see the effect of a field. And I'm saying this because you cannot only create fields inside of a field list. You also have a fields create menu here where you can create fields. However, with the cloner selected, I'm now going to create a plane effector and go to the fields list just to show you that those fields that you see here in this menu here on the very right, the field objects, this is what you have here. And so, yeah, let me just go through a few fields. Most of them are pretty straightforward. Here you've got like a box field, and the thing about fields is that if you select them here in the object manager, you can even adjust the type in here. You cannot do that if you select it in the fields list, and here you have all of these different shapes that you can use. I don't know if you can see it very well here, but yeah, we have all of these shapes here. We have also a formula field, which is one of my favorites, and simply by using a plane effector with a formula field, you can recreate the formula effector. That's the case for many combinations of a plane effector and a field. So the group field is something I want to show later. Python field is also, well, it's something I don't want to show today because it involves a lot of programming. What I want to show you are these two fields, the random field and the shader field, because there are some special things about them. So the random field by default is creating a noise. That's why you can choose from a noise type, like similar to what you know from the noise in materials or in the displacer and so on. And then there is random. Random is totally random, and noise are these noises that you might know. And the cool thing here is you can just adjust the scaling and so on. So I typically create some like bigger scales here. And yeah, now you can see the effect. We can also do relative scales to stretch noises. We can even let the noise animate. So if I press play now, you can see that the noise is animated. And you can also set a loop period. So if I set this to 90, you shouldn't see like a loop in here, like a switch in here. So it's now looping the full 90 frames here. So that's a pretty cool thing. And the other thing about the noise is that if you go to the Remapping tab and adjust the inner offset a bit, maybe let me let me adjust the scaling here again. Let's make the scaling uniform and make it a little bit bigger. So one thing I really like about the remapping is that you have those different contour modes here. And what you, for example, can do is you can set this to step and then adjust the steps here. So you can like create like a pixely Minecraft-like landscapes and so on. This is something you can do with step mode or with Quantize. So did you talk about the difference between Quantize and step, Thanasis?
No, I didn't.
Okay, so because they look pretty much the same in the first place, but let me deactivate the random field and let's create a linear field. So here we go. We're gonna have a look at this from the side, and let's set the remapping in the linear field to step and set the step to, let's say, 6 or so, like so. Okay. Now, if let's bring this up to 100, and if I go to Quantize, you can see that it almost looks the same. Actually, it looks the same. So what is the difference between the two? The difference is coming up once you play with the min and max values. So if I'm in step mode and I use the min max values, you can see that the steps are going to be the same, but in this case, the heights are just adjusted. If I go to Quantize, that's different. If I now go down with the max value, you can see that the steps are adjusting. And down here, for example, I just have 3 steps. So that's the difference between the two, just so that you know. Okay, so we talked about that. We talked about the random field. The next thing I want to talk about is the shader field, because the shader field is also pretty special. So let me just delete those two and create a shader field. So here we go. And in the shader field, I'm going to add a shader. So we can just click that and we go to the field, and here we choose a shader. Yeah, now let me see if I can. That's not the right thing. Let me just do that offline. Where do I have it? Just a second. I'm sorry. Oh, come on. Anyway, we can take another one. I just need to find it. Yeah, here we go. So we're gonna use this one. And no, so what I just imported is an image that looks like this. So we have this, and we want clones to react to that. But as you can see, everything is stretched here, and at least I didn't find a way to change that. So what you would have to do here is to adjust the clones, because, or the clone counts, and now you can see that something is happening. Let me adjust the plane effector to just scale these. And let's go to scale, uniform scale, and set this to -1. So now we can see it a lot better. But that's, well, most of the time not what we want. So I'm going to show you a way how you can really control and yeah, how you can really control the mapping of this, because by default it's just always mapping in Z direction. So let me create a new project here, and let me also create a plane, and let's set this to, let's say 40 by 40, something like that should be good. Okay, and now I'm going to clone on that. So in this case, let me just create a matrix object, and I'm gonna set the matrix object to object mode, and now I'm gonna use the plane here and set the distribution to vertex. So maybe let's make this plane a little bit bigger. So now we have this. And the cool thing about that is that we can now create like a material. And in here, we can just drag and drop this image. So now we have it here, and we apply it to the plane. So now if I deactivate this, you can see that it's applied. Great. And now what we can do is we go to, well, first of all, we create a plane effector, of course, and adjust it again to have uniform scale and bring this down to -1. And then I'm going to add the shader field again. Here we go. And what we can do now is, we're not going to use the custom shader here, but we're going to use the color of a material tag. So in this material, I applied this texture to the color channel. Then I applied the material to that plane, and our shader field, when I set the channel to color, is now asking for a material tag. And I can just drag and drop that in. And now you can see that those clones are, or matrices are, reacting to the pixels of this image. And of course, we can also now invert the remapping like so. And if we now make the plane invisible, well, you can guess that that's the image. But this technique would work for well, any other shape. So that's something that is important to know. And the next thing I want to do is I want to show you some nice combinations. So let me revert to saved in this one here. And what I want to do is, again, I'm going to create a plane effector because you can visualize this stuff best using a plane effector actually. So let's say you have like a field and you want to mask that field. For example, the torus field. Let me make this torus field a little bit bigger. We can just scale that, just make sure that only the torus field is selected. We can also adjust the inner offset, stuff like that, whatever we want. And now the other thing I want to do is I want to just create a slice of this. But as you can see in the torus field, if we go to the field options, we only have options for the radius and for the thickness and the direction. And yeah, so we don't have a slicing option. But what we have is a radial field. So we can add a radial field. And now if let's just set this to normal. And if I go to the field options and play with it here, you can see what's happening. So we are creating like a slice. Great. So what we can do is we can define the start angle and the end angle, and we can create some sort of like transition between the two. Another thing we can do here is we can adjust the iterations. So if we set this to 2, for example, we get this. If we adjust it to 4, we get this. So we can create those petals here. And we have an offset. Great. So in this case, I actually don't really want to use the color. And I also want to bring back the iterations. Let's keep the colors in here. So there are 2 ways actually to mask this torus with the radial field. The first one would be by just multiplying it. And if you have a look at the values, at the shape, everything seems to be good. But if you have a look at the colors, those colors, well, are not working as expected. So another way to do this is to select the torus field, and then you can click this little button here and create the option to add a mask. And now we can just add this radial field as a mask, and now you can see that the torus is not, or it's not black, but the white is kept. Okay, now let's have a look at the color remap in here. Oh yeah, the thing is, you typically don't see the color remapping in the viewport. Let me adjust this to instances. Maybe it's just the instance mode. So if we have the cloner set to instance mode instance, you can see the colors. If we set it to render instance, we cannot see the colors here anymore. With multi-instance, the colors are back. So keep that in mind, that whenever you are in render instance mode here, then you can't see the colors in the viewport. So this is actually what I would have expected to get. And the cool thing about this mask option is that we can add to that. So let's say we want to add like another random field, and we just want to add that as a mask. So we can now mask the torus with the radial field and the random field, and we can adjust the layer blending mode for the random field so that it's just affecting the radial field that is beneath it. So if I set this one to multiply, we get this randomization only in the slice of the torus. So there are quite a few cool things that you can do here. So keep in mind that mask mode is something useful. All right, now let me show you something else, because the good thing about fields is they are separate objects. they don't have to be children of that effector here. We can move them out. They are still going to work. We can move them around. It's absolutely no problem. They are 100% independent from the plane effector. But that also means, because it's separate objects, we can use them in multiple effectors at the same time. So let me select the cloner and the plane effector. And instead of another plane effector, well, that was a mistake, sorry. Let's select the cloner and create another, well, a random field. So we are creating randomness now. And let me go to the parameters. I'm going to switch off position and switch on rotation. Let me set this to 90 by 90 by 90, something like that. And we want to restrict this randomness also to the very same area. So there are two ways of doing it. One is, well, a little bit destructive, and the other one is very flexible. So let's go to the random effectors fields list, and we see that it's empty, but we can go to the plane effector, and up here we can just copy the whole field list and paste it into the random effector. And there we have it. But now you can see the two are the same. Maybe let me just move the fields up here so we can see some differentiation. And maybe let me make those two children of the torus field. And the thing is, now if I want to, let's say, add like another spherical field, here we go, to this one, you can see that the spherical field has not been added to both of them. But I want to add it to both of them. And let's say we have this field set up in multiple or in much more setups than just those two effectors that I have. Then it might be good to have like one place where you can have all the fields and then just reference this whole bunch of effectors, the whole bunch of fields in effectors. And this is exactly what you can do when you use a group field. So let me create a group field. This time I'm going to create it here. So this is the group field. And the group field is just a field that has another fields list in it. So I still have the old, or the stuff that I copied in the clipboard. So I can just paste it. So now the whole torus field setup is in here. And I can also add the spherical field to this. So now I have those two in the group field. And what I'm going to do next is I'm going to go to the random field. I'm going to delete the all fields in here. And instead, I'm just going to add the group field. And I'm going to do the same with the plane effector, like so. And add the group field. And maybe I did something wrong here. Let's see. Yeah, in the group field, the layer mode of the spherical field is set to normal. It needs to be max. So now we have the other thing back. And we can also now adjust the spherical field a little bit, like so. And you can see the randomness that has been added. However, now in the group field, if we add another field, let's say in this case we want to add like another spherical field, we have that in both of the effectors because it's part of the group field. So whenever you can and whenever it makes sense, when you have like scenarios where you're using a field in multiple places, then it's a good idea to think about the group field. This is also something that you can use, for example, for if you want to mesh a noise. Then as is already said that you can create volumes using fields. Maybe that's something I can quickly show before I hand back to Thanasis.
We did get a question.
Yes, please.
So let's see here. Escape from Post was wondering, you can use fields and effectors as deformers. So how would you use one to make like an electricity arc, an arc of electricity, a lightning bolt?
Can we also add that we can deform splines with an effector, and that we can use the MoSpline?
Okay, yeah. Two things. So let me go to this one because I actually prepared something for that. So here I have a cloner with some cubes that have been deformed using a bulge. So we are showing all of this in MoGraph because it's the easiest way to visualize what's happening. But you can use fields pretty much anywhere inside of Cinema 4D. So it's a unified weighting system. That's what you have to understand. So even in deformers, here's the bulge deformer, you have fields. And now let's just add a spherical field here. But here's the thing, there's a difference depending on where you have that field. So right now, the cubes are cloned and the cubes are deformed by using a bulge. And then the spherical field is a child of the bulge, which means that if I adjust it, if I increase the size or the radius here, you can see that the same stuff is happening to all of these clones here. On the other hand, if I move this out of the hierarchy, you can see that this is happening. So what I can do here is I can really mask the effect like really as an overall effect, and I can move this around, and this way I can mask all of this these deformations, which is pretty cool. And the other one with the electric arc is something I would realize with MoSpline. So if you have let's just create a very simple one, just a straight line here, and the MoSpline is a spline that is part of the MoGraph context. So all of the spline points are treated as MoGraph objects, so you can affect them using effectors. So what you can do to create an electric arc is you could, well, let's just create an arc. So here I'm going to create an arc. Where is it? There we go. Let's make it 180. And I'm gonna use that to create the MoSpline. So I'm gonna adjust the MoSpline's mode to spline. And then in the spline tab here, I'm just gonna use the arc as the input. So now we have a MoSpline with, shaped like an arc. And I can now use, again, a random effector to create something like this. And then I could use, let's use the spherical field again with a higher radius, like so, and move it up a little bit to create something like this. And if I press play, you see that it's static. But if you want this to be animated, you can simply jump into the random field, and in the effector tab, you go to, you adjust the random mode, and you can set this to noise, for example. So if I press play now, you can see that it's already moving, but we can bring down the scale, for example. We can bring up the speed, like so. We can set this to indexed, which will do a little bit more of a variation here. And this is how I would create like an electric arc. I hope that answered the question.
That totally did. Thank you so much, Jonas.
Okay. So yeah, the last thing that that I want to show here is that if you have a random field, there are some pretty cool things that you can do with that. First of all, we have these view settings, so you can visualize the noise here and make it much bigger, like so. And then what Jonas just said, is you can create volumes out of this. So let me create a volume builder and throw the random field in here, and then we can also mesh this. That was the wrong way. So here we go. Random field in the volume builder in the volume mesher. And now we can have a meshed noise. So that's a pretty cool thing to do. And now, well, we don't have the time for that because we still have like half an hour of stuff. And yeah, but you could use like the random field in a group field and this in multiple of these setups, and then remap it so that you have the counterpart of this, like similar to if I just create a copy and in the remap tab, like invert one side, like so. You could do this with multiple layers so that it's all working correctly. Cool. So I want to throw the screen back at you, Thanasis. Are you ready?
I'm always ready.
Okay, so you've got the screen back.
Thank you so much. So I have a couple of things, 3 things to show, which are have to do with the actual certification, the understanding of the clamps. I'm going to show you a practical example why understanding the clamps is important. So I have this very simple clone grid, and what I'm going to do is add a rotation to these buggers over here. I want to turn off the color. I want to go to rotation, and you can see I'm going to rotate them. It's always the third way, right? It's always the third one. So I'm going to make these 180 degrees, so they just flip around. So I'm going to get a field, and let's grab a spherical field. And what I'm going to do is pass this through this. So I'm going to go and animate this. You can pull it out the hierarchy, it doesn't really matter. And I'm going to set a keyframe here. I'm going to set 90 to be the same keyframe and 45 for this to be on the other side. So this is going to sweep through. And it's going to go around, and it's going to go around. Fantastic. Now, what I'm going to add to this to make it interesting, and this will introduce, here we have the, let's say, object or spatial fields. Here we have some other data generating fields. And over here we have the layer modifiers. So these modified, that's why they're white. I'm going to add a delay. And the delay, I'm going to add a spring. Now what you're observing here is that they only do half of the rotation when they, let me put this at 150. So we have a bit of delay. Look at that. They're not flipping 180 degrees. They're flipping halfway through. This is a product of the clamp. Because these cannot go in negative rotations, and the springiness when they're recoiling back wants them to go, but the value is not there. The value gets clamped at 0 degrees. So if I unclamp this, now you'll see them rotating. Look at that. So this is one of the applications of the clamp when you want to create some sort of effect where the value is going to go beyond under 0 degrees in this case, because we're rotating, or positioning. So when you're trying to do something like this, always remember to unclamp the final list so you don't get this effect where they're all, when they're recoiling, you will see, look at that, these ones that are recoiling are stopping them. Whereas if that is off, they're allowed to go in negative values. So that's a very important thing, and that is something we test the understanding of the clamp. Now, the other thing I want to show is a very simple sweep. So here I have a very simple situation where I'm just swiping from one setup to the other. And this can be then propagated. This currently thing is just a matrix, but it can be propagated into volumes to create morphing text and so forth. And the setup is actually quite simple. I'm just going to copy these 3 little buggers in a new scene because I'm too lazy to do them again. And we have these 2 text objects. And what I'm going to do here is define let's go and define a scaling so they disappear. So scale and uniform scale -1. This is an exponent, so this is 0. All right, let me turn these off because I don't want to see them. So the plane is making everything go to scale 0. So let's go here and add the first mask. So I'm going to use a point object. And if you select this and go to the layer, you will see that we have now it goes to points. So depending on the points of the object, it uses each point as a little spherical field. And this controls the radius. I'm going to go to surface. It samples the surface. It's slower and volume is even slower than that. But it's for this case, it helps. And of course, I want the opposite of what we see. If you want the opposite, you just go to the remapping and you invert it. Excellent. So we have our A made of clones. So I'm going to drag my B, or I can make a copy of this, pressing Control Command, and drag the B on top of this. So now we have the B. So basically, oh, it flipped both of them. Yeah, it flipped both of them. So forget about what I just said. Let's do this again. Drag this in, point object, select it. Go to, let's go and make it inverted, and let's go to the layer and set it to surface. Good. Now let's drag in B, point object, select it, surface, remapping, invert. So we have the A and the B. I'm going to turn off the colors. Now, how do we swipe through them, all right? Well, this is fairly simple. I'm going to take the A and mask it. And this is one of many ways. You can do multiplications and stuff like that, or put them in a little group and do whatever you want to do. I'm going to use a linear field somewhere here. The linear field is, for some reason, I cannot see it, but there it is. So turn this off, and I'm going to put the linear field in the mask. So it's masking this. So now the linear field is controlling which one is visible, here or here. And you can replicate this in Photoshop or After Effects. You can do exactly the same thing just by swiping a gradient, animating a gradient. And the final thing I'm going to do on top of this, just for the fun of it, is add a delay, make it springy, increase the springiness, and let's go and animate this little bugger here. I'm going to go to coordinates, add an X. Again, I'll put it here and go to frame 45 and send it to the other side and add a keyframe and press play. And now we have a little swipe. So this is a technique you can use with objects as fields, and then masks, and then some animation on a masking object, and so forth. So the last thing I want to, one very important thing you do need to know, because it comes up as a question very often, is what is the difference between using a plane effector with a random, a random effector, or a plane effector with a random field? So that's a very important distinction, because you can replicate a lot of these using the plane effector and the appropriate fields. But there is one very important difference about using the plane and a random field, and using a random effector. And let's go and see what this difference is. And I'm gonna, so look at this, and I'm gonna sort of simplify this as well. Maybe I need to make this 1. And what I want you to observe over here is, I'm going to move them not that way, but this way. That although they're undo. So although they are moving in random directions, they're moving towards the same direction. That is because this defines which way they're going by controlling the Z and the Y. And the random effector masks that value. So 100% of the effector's influence would send everything at the top right. That's a final, right? So you can go, and here's how you test it. If you go to the effector and start making this smaller, you can see that this is the direction that things are going to go, right? Forget about this purple line. It has nothing to do with that. This is the direction. How much of this strength is going to propagate to each clone is based on the random field. So the possibilities of these clones only lie within that diagonal. And that's because the final value is a set value. And this just masks that final value. So the clones can be anywhere on this diagonal. If I don't use this and I use a random effector, the random effector by design can turn this off. And I think it was, it was Z and Y. So if I'm not mistaken, 130 and 130, pretty much the same. So 130 and 130. And even if I go to set the minimum, another thing you need to remember that the random effector by default is always minus 100. What the random effector does is that it doesn't randomize all the values. It doesn't randomize the end product. It randomizes each value separately. So for each clone, it gets a random number between 0 and 130 in this particular case, and a random number, another random number between 0 and 130 in the Z. So if you want to do this, where your randomness goes in 2 or 3 dimensions, you're going to use a random effector. If you want them to move on a specific tangent, on a specific direction, and you want to randomize that direction, then you're going to use a plane with a random field. Now, having said that, if you're going to use only one direction for these to go, let's say they're only going on upwards, right? Then either methods are going to work, because we only have one direction to go. It's going to be slightly different, but they're all going to lie, whether you're going to use this method or you're going to use this method, they all lie on that because we're only moving one direction. So there's a significant difference between the way the random field works with the plane effector and the random effector works when we're using more than one dimension. So remember that, it will help you understand a few things. The last thing I want to say is I'm going to provide an alternative solution with this without a MoSpline. I'm a huge fan of the MoSpline. You can do amazing stuff. And if you watch some of the presentations and tutorials and all that, I just like to squeeze it in there whenever I can. And I have 2 setups here. I have this setup and I have this setup. They both produce an equivalent result. So one uses a random effector, and one uses a random field and a plane effector. So this one will allow you to move things like that. If you want a 3-dimensional ball, the other one is 2 dimensions, or it's going to be slightly different. So let's go and do that. Now, when I want to draw straight lines, a little trick that my friend Patrick Goski told me is that create an n-sider with 2 sides, and this creates a straight line. And just go here, change it to uniform, because otherwise you're going to have just 1 point because it's straight. And let's set this to 64. And what I'm going to do is just go and add, let's do it with the random effector because it's fun. And set it to point. And let's go here and say, where do we want these to go? We don't want them to go in the X. We want them to go in the Z and the Y. So let's turn this off. And now you're going to see they're going to go everywhere, but they're not going to move on the X axis. The random effector itself allows us to add modes with animation. The noise is a nice little mode. And you can see that we have the animation speed. And this is too soft. What we have to do is scale this down to a very small value. So you can put 1 or whatever you want. And let's increase this to, let's say, 1500. There you go. So the last thing I want to do is make sure, and they're going over there, watch this now, the random effector here, if you press indexed, then it allows you to create the randomizations per point. So that's going to give you a 3D bolt. Otherwise, it's just going to be on one tangent when it comes to deformations. Excellent. So what I'm going to do here is use fields to keep this and this part unmodified. So go to fields, and what I can do is get a box field. So the box field is first, and there you go. That's all you have to do. And you have a lightning bolt.
I'm sorry, did you say the box field?
The books field,
Box
exactly.
field. Okay.
And you can control how much of the books field is going to control and do all sorts of fancy stuff.
With
So-
the box field.
So there you have it, a way to create a lightning bolt. And of course, you can go and add all sorts of silly things like delays, springs. I don't even know if this is going to work. Is it going to work? I don't really care. Oh, yeah, I don't really care if it's going to work. But nonetheless, there you go. What will smooth do? Will it smooth it out? Interesting. Not doing anything interesting enough. So anyway, and there you go. There you have it. You can add more boxes and mix them together and make this sort of start bzzz, right. The noises, it's all in the noises, bzzz, so forth. So that's what I have for now, unless an interesting question comes up. Let's see. Anything anyone is aware of? Any question? Way to control the endpoint of the MoSpline. Well, the MoSpline, let me just say something about the MoSpline. The MoSpline has many modes, and one of these modes is to use, so I'm going to copy this, go to a new document, and paste it, and make it editable, all right? So we have this little line here, and let's subdivide this a few times. So somewhere here is the subdivide, and it's US. So US. Good. We have this. Well, the good thing about the MoSpline is that it has a spline mode. In the spline mode, you tell it which spline to read. So at this point, wherever the original spline goes, the MoSpline is going to follow. So there are ways to do that. And I shouldn't have subdivided it so many times. I think I shouldn't subdivide it any time. So MoGraph, MoSpline, MoSpline, spline mode, drag your spline in here. And the other thing you can do with the MoSpline, again, just for the fun of it, is you can drive another spline. So this is another spline. And just to make sure that I'm not tricking you, I'm going to delete all the points. There's no point in the spline. But you can tell the MoSpline to drive a destination spline. So now, even if I make these invisible, this spline is the final product of whatever the MoSpline is doing. So look at all these intermediate points. If I go to MoSpline here and say spline, I'm going to go with count, and I want to make this 20. In theory, this should have 20 points. There you go.
Yeah, that's a really interesting one.
Yeah, you can do resampling. I mean, we're totally off the field subject, but the MoSpline is such an amazing tool. So from this point onwards, by amending this simple spline, doing whatever you want with it, you're going to have a destination spline that has a predefined number of points. And if I go to the MoSpline and add a random effector and move the points around the MoSpline, there you go. So final spline now has that, but I want the final spline to be an Akima spline. So now it's the same spline, but it's like this. And I'm going to tell the random effector to dance and sing along and create a nice little noise here. So animation speed high, scaling low, press play. And now we have a spline which is controllable and does all sorts of fancy things. Tell the random effector to be indexed, and so forth. So from simple spline, drive a MoSpline. From the MoSpline, drive another spline. And in between, do whatever you want. And yeah, so, and this is just one iteration. You can feed these through others as well until your mind explodes.
Yeah, you can do so many things with that. I even saw, I can't remember who it was, but somebody created a reaction diffusion spline effect using the destination spline. That was pretty impressive and looked incredibly cool.
Yeah, what you would do in that particular case, as far as I remember, it went to the MoSpline and it used a push apart effector. So you use a push apart to push these apart, 20, and then it was fed in another spline. I don't even remember exactly, but it was using a push apart to do that. And the resampling was happening at an even, let me think, if it was a step of 5 centimeters. So it retains the stepping. Yeah. Anyway, there was some sort of feedback loop with a couple of MoSplines feeding one into the other, and yeah, something like that. But this just shows that the permutations are literally infinite, and that's why we focus on teaching you the fundamentals, because the creative ways you're going to use these things are that we haven't invented them yet. Let me put it that way. So once you understand the fundamentals, then you can start experimenting, and you will come up with all these amazing solutions and setups that you can make and do all the interesting stuff you want.
Yeah, so now the MoSpline hijacked our field session quite a bit. So do we have any questions related to fields at the moment?
Yeah, I feel like we've been sort of in the background talking a lot about this this question with a spherical field to control a cube spinning up and then down. And I suggested, well, the plane effector in deforming the object, affecting only the rotation, with the spherical field animated over and then off of the cube would accomplish that.
Yeah, absolutely.
Do you want to? Can you do that real quickly?
I can do that. Or you?
Can you repeat that? Anyone? You can do it, because I wasn't paying attention.
Okay, so I just took the screen, Thanasis, just that you know. Are we talking just about a single cube?
Just a simple cube.
A simple cube. So
we're already in overtime anyway.
Yeah, it doesn't matter anymore. We can go until tomorrow from now. So
yeah, I was thinking a plane effector, deforming this in the object mode.
Yeah. So I would just create a plane effector as a child. You can do that if you hold down Shift and create it. Then it will be immediately a child. Then in the deformer tab of the plane effector, we adjust this to object. And you can already see that this is pushing up or moving up the cube, because the plane effector is set to parameter 100 in position Y. And now let's bring this up to, let's say, 500. And we also want to adjust the rotation here a bit, like so. Let's go with 360. And now you should be able to use a field. Where do we have it? Well, same thing as Noseman. Usually when I go through that list, I barely find the linear field for some reason. I don't know why. So in the field, I go to Y, and now let's see. Well, we can already see that that's working. Let's go -Y, and let's do it like this. So that's how we can do it.
Yeah.
Yeah, so one last thing that I wanted to show, and I just have to find it.
Thank you.
No problem, no problem. So one thing, I think Thanasis didn't show it, but here in the field layers, there are some fields that are referencing like other objects. You showed the polygon object, but one thing that I want to show as well is the spline object. I think you didn't show that, right? So you can...
Yeah, no, I didn't show that, no.
Okay, so you can see I created a flower spline here. That's the flower spline. And I'm just gonna place it down here again. And in the plane effectors field tab, I can just drag and drop the flower spline in, and now you can see that something is happening already. So there are two modes in splines when you import them as a field. It's the distance mode. Well, actually there are three modes. Along, so this will modify, or this will create a weight along the spline. But then there is also radius, and then a combination of the two. But radius is something that I like quite a lot, because what you can do here is you can increase the radius, and at some point you can see that those clones are going up and will also be colorized in this scene. But that's also something that is quite cool because you can use text splines and all splines, custom splines, whatever you want to use here, as long as it's a spline. You can also drag vertex maps in here, and you can drag everything in here. Like it's really cool.
What's a vertex map?
What's a vertex map? Funny enough, a vertex map is also something that has to do with weights, because it's basically creating a weight for each single point of geometry. I mean that. Guys, do you have another hour? So basically what it does is, let me just create like a sphere or something, and let's make it editable, and let's have a look here. So what you can do is you can store a weight value with each point of the geometry, and this would be done in a vertex map. It's actually a great spoiler for the next session, because in the next session we're going to cover that. So let me quickly go to the select menu and set vertex weight here. And this way...
This is like stamping down the weight, where the fields, it's more fluid and dynamic because it moves through the world. But here it's like that you're sticking that weight onto the points.
Yeah, well, it depends, because you can also use fields in a vertex map. But that's a topic for... Yeah, exactly, Darren. Isn't that cool?
Gosh. That's amazing.
Yeah, it is. So, yeah, here we have that vertex map now. You can see that those weights are stored in a tag. Yellow means 100% weight, and red means 0% weight. But that's just a spoiler for next time. You can create growth effects with that. You can create all sorts of cool effects with that, actually. Everything that has to do with the surface can be created here. But I think we're already 22 minutes over, so I'm going to wrap up now. Unless there's a last question.
I want to show what I made. I want to show what I made.
You want to share what you made? Let me...
Yeah. Just
Okay.
as
Well, we got to see it.
You got the screen.
Thank
That
you.
looks like my signature.
So it's just a permutation of the previous setup, but I've added spline dynamics to the original spline. I added 2 nulls to control the beginning and the end, and now you have a soft dancing lightning bolt that follows spline dynamics as well.
Oh, that's cool.
Yeah, so
Wonderful.
for cartoony things and so forth. But anyway, I think we have digressed quite a bit from today's...
Now can you pull it out into a straight line?
I don't know. Let's try that. I mean, oh no, it just grows because I've added the... Oh, look at that. It contracts, it expands.
So you'd have to probably like keyframe the strength of that random effector
NFT.
down, right?
No, this is an NFT. This is 5 Ethereum worth of NFT.
It's great. Sold.
So,
Sold. Okay.
right, I'm done.
Cool. So, yeah, let me grab the screen back here. So here we are, and I'm going to wrap up. So yeah, if you want to watch more of our exciting tutorials and webinars where we sometimes not just cover the topic that we actually wanted to cover, but also other topics, like today, then here is like the list of upcoming events. It's on maxon.net/events. And yeah, then you get here, you can register for events here or get to the link. If you missed a session, you can always go to the Maxon Training Team YouTube channel. And as soon as I close this session here, you will also see today's session in here. Then again, this the topics that we have at Ask the Trainer are at the moment based on the certification topics list here, because we want to like provide a little bit of a like knowledge base to get people prepared for a certification test if they want to. So if you go to that list and you want to see a specific topic covered, just let us know. Our email address is askthetrainer, one word, askthetrainer@maxon.net. And yeah, then there is another thing that I want to share. Again, I told it in the beginning, but there is a merch store. And when you watch our tutorials, we want to thank you. And therefore, we want to give you a t-shirt as a present. So you can click that link that Darren or Ellie are going to add to the chat, hopefully. And also type in the coupon, the discount code while going to the site. And then you can see all of the t-shirts, all of the stuff that you can order. You don't have to pay for the t-shirt. You can order one t-shirt for free, and you only have to pay for the shipping. Exactly. So
what a deal.
That's pretty much it. So we're all on screen now. Behave. Another thing that I wanted to mention, which is quite exciting. So the next session that is about certification topics, we're going to have another session dedicated to fields, and we're going to create more advanced setups like in 3 weeks from now, April the 14th. So definitely check that out. And typically we just have 4 Thursdays in a month, but March is special. We have 5 Thursdays this month. And this is why we decided to do a very special edition of Ask the Trainer. You can already see it. Wait, let me go back to this one. You can already see it if you go to the Maxon Training Team YouTube channel. The next one here on the 31st of March, it's a Meet the Trainers. And what we're gonna do there is, you can ask questions. We're gonna tell you what our way into the industry was, what obstacles we had, what went really well, maybe our first projects, maybe some random stories. So it's definitely gonna be a lot of fun. And yeah, with that in mind, I want to close this session. So bye everyone.
Bye everyone.
Bye, everyone.
Thanks for attending.
Bye, everyone.
See you next time. Bye.